Today, we're going to add staticky noise to our VHS post-process filter. Let's go. All right, so the effect that we're adding today is this snowy, staticky noise. And this would be caused if you use some kind of an analog cable that wasn't shielded very well, and it was other signals were causing interference. So you can see that there's this white staticky noise mixed in with our filter. So let's go ahead and add that to our effect. So here's the shader that we've been working on. This is part 3 of a series for our VHS filter. In the last 2 parts, we added tracking noise and phase misalignment. We also added this wave effect, these interlacing lines, some chromatic aberration, and we also added our YIQ color grading. So right here is the final color that we produce, and then we do this YIQ color grading at the end. And the effect that we're going to add today is right in between our chromatic aberration and our YIQ color grading. So we're going to take the color that's going through this wire right here and add that static noise in. All right, let's come up to the top here. And the first thing that we're going to do is we're going to take this tape crease noise that we've created up here, and I'm just going to drag out a wire, and we'll add a multiply. And we're going to be making a variation on this tape crease noise. Let me just open this up so we can see a preview of what we're getting as we go. So you can see we don't have any white staticky noise so far. Just temporarily, I want to show you what we're getting for this tracking noise here. So I'm going to take our smooth step and wire it into our final result. So you can see this tracking noise is just giving us these crazy horizontal lines. And then this one here, our tracking phase, if we wire that in, you can see that's what's giving us that slowly vertical scrolling bar that makes it look like our tracking is out of phase. So I'm going to take this, and we just want to tone this down a little bit. And so I'm going to multiply it by 0.7. And then we're going to add 0.3 to it. So we still want the result to be 1, but we want there to be less contrast here. So I'm multiplying by 0.7 and then adding 0.3. And then we're going to multiply that by our overall noise. And so the result that we're going to get here is a mask that we can use. So now you can see that my lines are quite a bit toned down, and then my vertical tracking bar is the same brightness. Okay, we can use this to break up the staticky noise. We're going to make a noise hash that's kind of a uniform noise, but then we're going to use this to break it up. So I'm just going to set that aside for now, and let's work on our noise hash. In order to create the hash, we need a time node, and we need an append node. We're going to put time in the second position of our append. And for the first position, we're going to come down here and grab the coordinates that we're using to look up our screen. So here are our screen coordinates. And in this case, we're just going to use the V coordinate, or the second one. And I'm going to drag that in and append it with time. And now we need our noise hash. So this is a node that we created custom in a previous video, so I'll link that here and in the description so you'll know how to make this hash 23 node. What this allows us to do is we pass in a vector 2 like we've created here, and it gives us noise in return. So let's just wire this into our final result and take a look at what that's going to give us. Cool, so we're getting these random colored horizontal lines. Now we don't need them to be colored, and so I can add a component mask here and just mask out the red channel. And now we're going to add a multiply, and we're going to multiply it by a vector 2 with a value of 1 and 0. So we want our noise to be in the first channel, but we're going to have black in the second channel. And now we're going to put an add node here, and we need to add this to our coordinates. But we're going to rescale the coordinates. So here are our coordinates here, this append value. This is the coordinate that we're using to look up our screen for our chromatic aberration. But we want to scale this so that it's... But we want to use the technique that I showed you last week for quantizing the screen. Last week's video was about pixelation and making the screen look like it's made out of much larger pixels. So we're going to use that technique here. So I'm going to take these texture coordinates and I'm going to multiply them by the size of the screen. So I'm going to add a view size node. So this is the width and the height of our screen. And I'm going to divide it by the size of pixels that I want. In this case, I want my pixels to be about 8 by 8. And so then we're going to multiply our screen coordinates by that value. And then we're going to add a floor node here so that we quantize it and make our larger pixels. And now we need to take the result here and divide it again by our size here. So the result of this, if we take these coordinates here and we wire them in, you can see that we're getting our nice UV coordinates. But if I wire this in, what you'll see is that our UV coordinates are quantized. And I can make it a little bit more obvious if I make this value larger. If I make it something like 64, now you can see that pixelation there. So what I'm doing is I'm taking the UV space and quantizing it, so I get these 8 by 8 blocks instead of nice smooth UVs. And now I'm going to take the result of this and combine it here. Actually, I made a mistake here. This multiply should be an add. So we're going to add our quantized texture coordinates here. And now I'm going to put another multiply in. And we're going to multiply by a vec2 that is 0.1 and 1. And there we go. And now we're going to add another #23. And this is going to give us our snowy noise. But this snowy noise is colored, and we just want black and white snowy noise. And so I'm just going to add a component mask and mask out just the red channel. So if we take this and wire it into our final result, perfect. Now you can see I'm getting this nice snowy noise. So that's the mask that we're looking for. And now we need to blend between the snowy noise and our color. And so we're going to add a lerp node here. And I'm going to take the color that I'm generating with my chromatic aberration before the YIQ color grading here. And we're going to plug that into port A of the lerp. And then for port B of the lerp, I'm going to create a vector 3 that is a value of 2, 2, 2. So this is like white, but it's extra white because it's above 1. I've given it a value of 2 here. So we're going to wire this into our lerp. And then we're going to use this snowy noise as our mask. But I want to adjust it a little bit. And so I'm going to tweak the contrast of my snowy mask with power. And I'm going to raise it to a power of 10. So what you can see if I wire this into my final result here is that I'm only getting the snow that's like the brightest. So it darkens most of the pixels in my snowy noise and makes only the brightest ones stand out. So those brightest ones here, when I do the lerp, are going to show up as this really bright snowy noise, and everything that's darker is going to show up as my regular color. So let's wire this into our end result. And now you can see that I've combined that snowy noise mask with the color that I was generating from my scene previously. All right, that's pretty good, but I want to add in some of the noise that we're getting from the scan lines and from the tracking errors. So I have this mask here, and I want to combine that with this scene that has the snowy noise in it. So what I'm going to do is add an if node here, and I'm going to say if my linear mask here is darker than 0.29, then use the scene color. Otherwise, use this noisy color that I've created. So I'm going to wire the noisy color into A is less than B. And then I'm going to wire my scene color from down here into the A is greater than or equal to B. So what this does is mixes together my horizontal line mask here with the snowy noise mask that I already have. So let's take a look at the result that I'm getting from this. Cool, so now you can see that I've still got that snowy noise, but it's being masked by those horizontal lines, so it fits more with that interlaced horizontal line noise vibe that I had going before. So this gives me my final color, and now I can take this final color and wire it into my YIQ noise color grading, and then take the result of that and wire it out for my final result. So now you can see that I've added this snowy noise effect in, and it's being combined with my interleaving, my tracking out of phase effect, my chromatic aberration, and I'm getting this nice snowy noise. So if we save our shader, we can switch over and take a look at our final result. That's pretty cool. Now, if you do want to tone this down, if it's maybe a little bit too strong, maybe your signal interference isn't quite this high, you can come over here and adjust this value right here for the power. And the higher this power is, the less snowy noise you'll get. So if I give it something like 800, now you can see that there's just a tiny bit of noise in there. And if I set this to something like maybe 20, now there's a little bit more. So you can see like the higher this number goes, the less noise you're going to get. But if you set it to something like 1, it's almost all noise. And maybe if you set it to something in between 10 and 20 is a pretty good range. Or if you want even less, maybe 30. But you can see that using that power value, you can adjust how much of that noise you're blending in. All right, cool. So that is the last video that we're going to do for our VHS series. I hope you've enjoyed this and that you've learned how to make your scene look like it's recorded on a VHS videotape. All right, let's switch over to Unity and I'll show you how to do the same thing there. All right, here we are in Unity, and you can see that I've added this same snowy noise effect to our VHS filter here. So let's take a look at our shader and I'll walk you through how this is done. So in previous videos, we created the tracking mask effect, we created the worn tape effect, the scan lines, the screen interlacing, and the chromatic aberration, and then finally the VHS color grade and YIQ space. And so what we're going to do today is take the color that we've created with our chromatic aberration and intercept it before we pass it into the VHS color grade YIQ space. And in between the chromatic aberration and YIQ color grading, we're going to add in the snowy noise. Okay, so you can see that we take our color from the chromatic aberration and we bring it up here and we blend between the scene color, which is going into the A pin of our lerp, and white, which is represented by this vector 3 set to 222. So this is the color of our noise and the color of our scene coming into A and our noise color coming into B. And then we're blending between those two using our linear interpolation node with this noise mask that we've created. So let's take a look at how we've created this noise mask. So if we come back here, you can see that we've created, we've taken our screen position and added our worn tape effect to it. And this gives us the UV coordinates that we're going to be using for the whole filter. And we take the green channel of that and we bring it up here and plug it into the X value and time is plugged into the y value of a vector 2. Then we pass that vector 2 into our hash23 node, and that gives us these horizontal lines that are animating like this. But we don't want them to be in color, we just want them to be black and white. So we're using this split node to take the red channel of that effect and multiplying the result by a vector 2 here with a value of 1 and a value of 0. So that gives us a black and white filter, a single channel, where we've got horizontal lines in the red and black in the green. All right, then we take that effect and we add our quantized coordinates here to it. And the result is texture coordinates with those horizontal noisy lines added to it. The quantization that we're doing is taking our UV coordinates here and then multiplying them by the size of the screen divided by 8. So we take the size of the screen, divide it by 8, multiply it by our UV coordinates, then we floor that, which is what's doing the quantization. It's rounding down to the nearest whole number, and then we divide by our screen divided by 8 again to come back to the correct size. And then we add that to this noise, these horizontal line noises that we've created before, to get our UV coordinates with this horizontal line introduced. Then we multiply by vector 2 with values of 0.1 and 1 to kind of tone the effect down. And then we pass that into our hash23 again to create our snowy noise. So this is what's creating this snowy noise effect for us. And then we just want it to be in black and white. So we split out just the red channel, and then that's going to create the mask that we use to blend between our scene color and our snowy noise color. But first we need to raise it to a power of 20, or this is the value that you can use to control how much noise is getting applied. So this is what our final mask is going to look like. And you can see the lower this number, the more noise we're going to get. And the higher this number is, the more subtle our noise is going to be. So let's just leave it at a value of 20 for now. And then that is going to be our mask that we're going to use to blend between our scene color coming in and the color of our snowy noise. Now we want to take that and break it up a little bit more. If we take this value here, you can see that, let's see, I'm just going to plug this directly into our scene color, and we'll save that and switch back to our scene. Now you can see that I'm getting this snowy noise, but it doesn't have enough of the horizontal interlacing lines in it as much as we want. And so what I'm going to do is take the result of that, and I'm going to blend between that scene color with our snowy noise and just the scene color with this mask that I've created up here. So this, to create this mask, I'm taking my tracking mask, which looks like this, and I'm multiplying it by 0.7 and adding 0.3. So that gives me a tracking mask that looks like this. And then I'm multiplying that together with this horizontal line mask that I've created here to get a mask that looks like this. So this is what I'm going to use to break up my scene combined with the snowy noise. So I'm going to take that and I'm going to do a comparison here to see if the values there are larger or smaller than 0.29. So if those values are smaller than 0.29, then we'll take the snowy noise combined with our scene. Otherwise, we'll just take the scene. So here I've created a branch, and I'm branching between the regular scene color coming in and the scene color with the snowy noise added. And I'm branching based on this mask that I've created here. Okay, so that's going to give me my final color, and I need to take that color and pass it into my YIQ color space grade. And that's going to combine the scene color with the snowy noise scene color, and then do that YIQ color space grade, and then pass out to our final result. All right, so that's it. That's how you add white noise artifacts to your VHS post-process filter. Thanks for watching the video, everybody, and I hope you have a fun time making your final scene look like it's been recorded on VHS tape. Have a great week, and we'll see you in the next video.